started. Welcome everyone to today's long range weather outlook, where we'll go over the long range outlook over the next couple of quarters, Q2 and Q3 of 2026. Really excited to have everybody here, and yeah, let us go get right into it. So, my name is Dr. Hansi Singh, and I am CEO and founder of Planet AI. So, I am an Earth system scientist. I spent some time at the US Department of Energy in one of their major national labs. I also did some time in academia as a professor. And I still am a part of the CSM working group, which is a major Earth system model that is developed at the National Center for Atmospheric Research in Boulder, Colorado. I decided to start Planet so that we could bring some of the major technologies that we were developing within the confines of academia into the real world to help with real world decision making. And those technologies are particularly the technologies that allow us to predict the weather well beyond your usual 10-day weather forecast. So, hence, here we are looking at the 6-month forecast. So, what we'll talk about today is, first of all, just a brief overview of how long range weather forecasting works. Then we'll get into the subseasonal outlook over the next few weeks. We'll look at the seasonal outlook over the next quarter. And then we'll take a look into summer 2026, where the major gorilla in the room is an El Nino that is brewing currently in the tropical Pacific. And so we will have a lot to say about that because it really is going to drive the weather over the next year, possibly longer. How does long range weather forecasting works? What is this magic? Well, it's not magic, it's science. And so the way that long range weather forecasting works is that forecasting in general of weather happens through an atmosphere model. So these are the usual weather models where the outcomes of those models, the outputs of those models are the ones that show up on your phone, for example, in your favorite weather app. And these are models of the atmosphere. The atmosphere is very mercurial. It has a very short memory. It has a memory mostly, especially in the troposphere, of maximum 2 weeks. And so what this means is that these models don't have much predictability beyond 2 weeks. In order to really get predictability beyond 2 weeks, we need much more complex modeling efforts. And this is where Earth system models come in. So Earth system models, we call them kitchen sink models because they literally have everything in them, and every time updates are made to these models, they get more and more complex, just because we realize that so many processes and elements are so critical to really understanding how our planet's weather and climate evolve with time. So what these models include not only the atmosphere, but also elements of the climate or the Earth system that have predictability beyond 2 weeks. So the ocean, for example, has centuries of memory built into it. The land surface has months of memory, as does the sea ice, months, even years, as vegetation grows and evolves with time. So what this means is that we now have the components needed to forecast weather beyond 2 weeks. Please note, we cannot tell you, for example, that a particular tropical cyclone is going to hit a particular location, say 6 months into the future. But what we can tell you is the risk of typhoons forming within that ocean basin and making landfall at near a particular location over that season. So we get really good predictive power, but it is not day-to-day predictive power. So please keep that in mind. This is science, not magic. All right, let's get into the forecast. So whenever we think of the long range forecast, I always like to start with modes of variability. So these are the key physical drivers that are going to determine how the weather fluctuates over the next year. And so if we think about these drivers, there's going to be three that I'm going to talk about today. The first, which I've literally been talking about, everyone's probably so tired of it who comes to many of these webinars, is the QBO. which is still in its negative phase because that's what it does. It's very predictable, and it has major implications for how the stratosphere behaves and therefore the likelihood of cold snaps that are driven by the stratosphere and that are highly predictable weeks in advance. Then we'll talk a bit about the MJO, which is a mode of variability in the tropical Pacific. If you are interested in things like the MJO, then please take a look at our YouTube channel where we have a bunch of webinars where we sort of really dive into the details of some of these different modes of variability. So we get into sort of the physics of the MJO, and here I'm just going to be looking at its impacts. Note that the MJO is going to be in a phase 7, then a phase 8, then a phase 1 over the next 30 days. And so we will look at some of the impacts of this progression that we expect. Then, as I said, the big gorilla in the room is El Nino, specifically the ENSO index, the Nino 3.4 index. We expect this to be in neutral conditions through April, but it is rapidly changing into an El Nino. If we look at the Nino 1 index, for example, we can already see that there is warming happening in the East Pacific, East Tropical Pacific. So over the next couple months, we're going to see this develop into a weak El Nino. By the summer, we're definitely going to be in a moderate El Nino, possibly even a strong El Nino. And that has major impacts on the Earth's climate. It has major economic impacts. I'll just show you very briefly a study that looks at some of those. And so it is really going to be driving our weather over the next year or more, because these are just really significant events. So first, let's start with cold snaps. So we're in spring. You might be wondering, why is Hansi still talking to me about cold snaps? Well, the reason why is because we're, first of all, actually in the midst of one in certain parts of our country right now. There's some parts of our country that are broiling right now and some parts that are very cold. And globally speaking, we are in a stratospherically driven cold snap. So I'm going to show that to you on the next slide. So first of all, what are these cold snaps? So what they are events that are instigated by polar vortex weakening. So this is the polar vortex. It's like a belt of air, rapidly circulating air that holds cold air over the Arctic. And what happens is that when the QBO is in its negative phase, the polar vortex is kind of weak, and so it's sort of sloppy, and so it tends to break down. And these breakdown events are called polar vortex weakening events. And these are then associated with cold snaps. These cold snaps can occur either over Eurasia, over North America, or both. So these tend to be sort of the canonical temperature responses that we see when these polar vortex weakening events happen. And we do, in fact, have a webinar also that dives into the details of this, where Dr. Aidan Sweeney goes into the physics of how these happen and their drivers and how we expect them to play out over time. So right now, these are conditions expected over this week. And, you can see this is like pretty much a canonical polar vortex weakening pattern or temperature response to a polar vortex weakening pattern that we can see here. And so what we see is cold conditions over Canada, over the eastern US. Please note, right now in the news, you're probably seeing a ton of stuff about the western US because it is very hot over there. And in fact, I'm here in the Pacific Northwest. It is very hot here, or unseasonably warm. And so, even though that might be in the news, there is this weakening event happening. Most of this is associated over Alaska, Canada, the eastern US, and some parts of Siberia. So this is happening right now. It might not be something that you're writing home about, but it is, in process. Now, we have a major polar vortex weakening event expected within the next 10 days or so. So this is the 45 or sorry, the 35-day forecast initialized on March 16th. The polar vortex weakening event is shown here, which basically shows that the vortex, which is usually cold, is suddenly insanely warm. And what we're looking at is essentially an average over the pole, the polar cap, of what we call geopotential heights, which essentially tell us about temperature. And so this is the polar vortex weakening event. And then you can see that, these kind of colors propagate downwards. Essentially, 2 weeks later, we expect surface impacts. Now, keep in mind that this is also around the time that we expect the polar vortex to die. So, sometime in the spring, the polar vortex usually dies, which just means that spring is here. And so, everything is warmer. There's no longer cold Arctic air that's stuck in the Arctic and that's sort of limited by the polar vortex. But however, this is very early for this death of the vortex. So we really think that this is probably a weakening event and the polar vortex is going to be back. It's going to be weaker than ever. And, usually the polar vortex dissolves sometime in mid-April or so. So we do think that this is actually a weakening event. If we look at the forecasts for the first, second week of April, we see something that does look like a canonical polar vortex event weakening. So warmth over the Arctic and cold conditions over Canada, eastern US. And this one looks like it's more focused on Europe and parts of Siberia. So we'll see how this plays out. We'll keep an eye on it over the next few weeks and see if there's going to be any significant impacts, particularly for energy markets over here in North America. So I'm going to move on now to the MJO. The MJO, with the negative QBO at the same time, the MJO has been quite strong this past winter. It is going to continue to be strong into the spring. And these warm conditions are expected coincident with the phase 8 of the MJO that we expect over the next 3 to 4 weeks. So, this kind of these warm conditions are expected over the US plains, Midwest, and Midwest in particular. So essentially, these kind of warm conditions that we're seeing over the Western US, we do expect that some elements of them are going to continue for the next few weeks. We also expect with this phase 8 MJO that there are going to be some dry conditions over the southeast US and also, interestingly, possibly some wet conditions over Florida. So this is also associated with our MJO phase 8. We talked about spring and the potential early start to spring. So, if we take a look at the temperatures in April, what it looks like is that there is essentially a dissolution of the polar vortex. We see a warm Arctic, and we see cooler conditions further south. So, essentially, the polar vortex breakdown is what signifies the start of the spring. And so it sort of makes early spring have a more complex pattern than you would expect than just like, oh, it's warm everywhere and therefore it's spring, right? And so what we expect on the ground in particular is that most of the lower 48, the Arctic, Scandinavia, Siberia, we're going to see some warmer than usual conditions, early spring conditions. However, there are many locations that are probably going to see some cool conditions persisting into April, and that includes Canada, Alaska, and parts of Southern Europe. And as I said, this just has to do with how the polar vortex dissolves and sort of allows this Arctic air to spill out elsewhere. And so we are going to continue to see some of those impacts into April, especially with this very late sudden stratospheric warming that we're going to be seeing. I think there's going to be some interesting, fluctuations and volatility associated with how that polar vortex breaks down this year. So, Now, let's take a look at what to expect in terms of severe convective storms and tornadoes. So, this is something that usually in our large scale Earth system models, we do not model directly. However, there has been a ton of research on understanding linkages between ocean temperatures and tornadic activity in the springtime. You might have seen recently the news has just been wild with tornadoes. And, there's been a lot of talk of like, are the forecasters prepared? Why are, so many lives being lost? Why aren't we getting enough of an early warning with these systems? And, one thing to note is that we knew that an El Nino was very likely on its way, even, in November, December of last year. And when we transition from an El Nino, or sorry, a La Nina, or even especially a weak La Nina to an El Nino, we expect a lot of tornadic activity within the plains and the Midwest. So there is a pretty classic paper on this, Lee et al. 2013. This is from their paper. It's a really good paper because the nice thing is they do a full statistical analysis, but then they also talk about the physical mechanism, which makes a lot of sense as well. And so the physical mechanism here is that when the ocean temperatures look like this, which is like almost exactly what it looks like right now, and into next month, what we expect to see is that we're going to get moist air coming in from the Gulf, and we're going to see sort of this dry air coming in aloft, so up high in the atmosphere. And the collision of these air masses gives rise to some really pretty severe convective weather, and particularly the type of supercell systems that lead to tornadoes. So, there's been a lot of, chatter like, oh, so many tornadoes, is it climate change? It's not climate change. It's literally the fact that we're probably because we're transitioning from a weak La Nina to an El Nino. And so, of course, after the fact, there's always studies and, people will look at mechanisms and, oh, why was this year so bad? And, I think there's some good evidence in the literature that this is something that we likely can expect in years that look like this. So, yeah. I think this is kind of important to put out there. And another thing that I want to point out too in the spring is that many areas, particularly in southern Eurasia, are going to be seeing sort of these colder than usual conditions, but exception to that is the Tibetan Plateau. So the Tibetan Plateau, we expect warmer than usual conditions over this region in April. And so the reason why I want to highlight this is, first of all, I'm going to talk a bit about the impacts of El Nino. El Nino tends to lead to water deficits in this part of the world. And these warmer than usual conditions over the Tibetan Plateau also are going to stress water resources. How? Well, it's because generally we tend to get earlier runoff when the Tibetan Plateau is really warm. And so, what we can sometimes expect is that water resources are sort of going to be, used up early in the season. And by the end of the year, we may end up with major deficits. So, just something to keep in mind as the spring progresses, that this area of the world may be an area where we should be expecting some water resource constraints over the next 6 months or longer. So, now we finally get to the El Nino, which is very exciting. So, as I said, we're very likely to move into an El Nino by May 2026. By the end of the summer and the start of the fall, we expect this El Nino to be moderate to strong in intensity. And so our forecast for the Nino 3.4 index is right around 1.5 standard deviations from the norm, which is kind of right at the point where you say, it's moderate to a strong El Nino. So this is kind of what we are expecting. And one thing that you might have seen in the news lately is like, oh, it's a super El Nino. I don't think it's going to be a super El Nino by the fall, or at least by the early fall. Generally, what we tend to see is we will see this sort of building up over this coming year. And then it likely will be in 2027 where we will see the full development of potentially a super El Nino. And of course, we'll have to keep watching the long range forecasts, particularly the behavior in the ocean, to really understand the likelihood of this, sort of stabilizing at a moderate or a strong El Nino versus a super El Nino. So I think it is too early to speculate about it becoming a super El Nino because that is very unlikely to happen by September. So, what are the impacts of this El Nino? So let's look particularly at precipitation because there's some major precipitation impacts, which means that we have really good precipitation predictability thanks to this weather pattern, this El Nino. So we know, for example, that the Indian subcontinent is going to have a later monsoon or particularly later onset of the monsoon, and the monsoon is not going to be as strong. And we expect sort of similar outcomes for parts of Southeast Asia. And so, what this means is that definitely we can expect some water resource challenges. Remember that I mentioned earlier about the Tibetan Plateau being warmer than usual this spring and therefore earlier runoff. So, combined with a weaker monsoon, we may expect that kind of the whole of South Asia will probably be experiencing some water resource challenges, particularly linked to this El Nino and how the spring is playing out. And this includes impacts on hydropower, as well as impacts on manufacturing, impacts on agriculture, essentially anything that depends on the availability of fresh water. Another area where we tend to see major El Nino impacts is Australia and Oceania. So, in particular, for Australia, there tends to be an increased risk of bushfires by the end of the year because of the drying patterns brought on by El Nino. And we also see drying within Oceania as well. So, this is actually just the June forecast, not even, the summer slash early fall forecast. And so what this means is, of course, water resource challenges, as well as increased risk of wildfires, particularly for Australia, which tends to be very vulnerable. If we look at Central and South America, we also see increased risks of drought. So, in particular, for southern Mexico, Central America, and the north part of South America, we expect drier than usual conditions as well as warmer than usual conditions associated with this coming El Nino over the summer and into the early fall. So, what does this mean? This means that we may expect, once again, water resource challenges. This is an area where there is a ton of agriculture and mining. Both of those are very water intensive, so we may expect impacts. It'll be very interesting to see what happens over Colombia. Colombia is where there is a ton of coffee production. And the thing with Colombia is that they experienced a ton of rainfall over the past, 3 to 4 months. So it was much higher than normal. And this was actually something that we were watching in our forecast for a long time, like, oh, what's going to happen to my coffee? And so already they have sort of downgraded the amount of production of Arabica that they expect. And now we're getting into really dry conditions. So this is really kind of a whiplash for them. We'll sort of have to see how, the really wet conditions combined now with very dry conditions are going to be on this coffee crop. I'm hoping for them that dry conditions are maybe a reprieve, but unclear. Somebody who is much better at agriculture than me can probably state what the impacts are much better than I can right now. The other areas to really think about here are Panama and particularly the Panama Canal. So whenever there's a drought over this region, often what ends up happening is that they start restricting traffic through the Panama Canal because the locks in the Panama Canal are actually fed by fresh water, which is a little bit surprising for folks, but that is how they've always done it. And so what this means is that generally when there is less fresh water available for those locks, what we tend to see is that the authorities limit the weight of the vessels that go through because they don't want the vessels to be really low in the water because then, if the water levels are low and the vessels are really heavy, then you can literally have accidents, right? Where the vessel is hitting the bottom of the canal. And so this is kind of definitely something to watch because we may expect to see some limitations in ship traffic allowed in this area associated with this coming El Nino. Over Central Africa, an area with a lot of very sensitive agriculture and mining industries, a lot of use of hydropower. We actually expect resource challenges associated with this El Nino. In particular, this area here just south of the Sahara is called the Sahel. And over the next few months, it is going to be significantly drier than usual. And of course, this will have impacts once again on water resource management and any water sensitive industries. Finally, I just want to point out this is a nice figure if you want to take a look at it sort of in your own time that really shows what an El Nino summer is going to look like. Obviously, I've just had sort of a quick chance to go through some of the regions in the forecasts. But yeah, there's so much more when it comes to El Nino in particular. I mean, this phenomenon has just been studied to death. And so, we have some really good sense of sort of what to expect over an El Nino summer. And I also want to point out that the coming hurricane and typhoon season is really going to be impacted by the El Nino. In particular, I think that we are going to have a weaker than usual Atlantic hurricane season. However, the Pacific typhoon season will be stronger in some locations, particularly Korea and Japan. So, if this is of interest to a lot of folks, this is definitely something that I'd be happy to jump on a call about or, have a future webinar about. Finally, I just want to highlight this one really good research paper, specifically at the intersection of climate and economics, looking at the global implications of El Nino, particularly economic losses. This looks at the strength of El Nino impacts over particular countries, and these are the economic losses. And you can see that the economic losses are basically any countries in the tropics plus the US. So I don't know what that says about the US, but here we are. And so the point is that we expect with El Ninos that there are going to be major economic losses and that these economic losses are in the trillions and that they continue over many years, even after the El Nino resolves into, neutral conditions or a La Nina. So very interesting paper. And, these things matter. So the weather matters. I probably don't need to say that in webinar like this. So thank you so much. Really enjoyed talking to everybody today. And so in a couple of weeks, we will be back talking specifically about the nexus between weather intelligence and energy, and specifically risks and opportunities in this area. So this is on April 1st, which is a Wednesday at our usual time, which is noon 30 Eastern. And I think there are maybe some questions. I'm not sure if there's questions. Feel free to ask any questions, but I will go ahead and, yeah, close right there. Thank you so much.